everybody. Now Anton Caceres is going to tell us about boosting our database performance with machine learning capabilities using Python and open source.
Thank you very much. Thank you for the introduction. And thank you for pronouncing my surname correctly. For new people, it's Caceres. And I know it's difficult, and I got a lot of comments yesterday about it, like, doesn't sound very Ukrainian. It doesn't, yeah, and I get a lot of stories about that. On every conference, I am pronounced differently, and that's okay. But I live in Germany, and my passport, it has my surname in Cyrillics as well as in Latin. And Cyrillics, it looks like this. And it's so common that somebody would say, Mr. Katzepek, please come in. So read it like in Latin. Then I even have like a notepad with the best ones. Like I have Karas, it sounds Latin. I have Antonovich, because somebody in Ukraine just couldn't read it, so they read Antonovich. Good. I'm really looking forward to see what will be the Polish variation of it. So if somebody has idea, go for it. So again, my name is Anton, I live in Munich. I'm organizing tech events, Python conferences mainly, and Python meetups in Munich. I did like more than a dozen of them. And I run an agency also in Munich. It's a small one, it's a friendly one. It looks, of course, exactly like this. That's our daily work. We are small. We're just a group of Python enthusiasts that gathered together to have like a flat hierarchy doing work for our clients. It's like a freelance, but on a bigger scale, with very, very, very basic hierarchy and very, very, very childish business planning. Yet we do the work and people are happy and they give us money, so it kind of works and scales. So, as a part of that agency journey and event organization, I gathered some experience about most trendy technologies like serverless computing, cloud, as well as databases and AI. Today, I'm going to take you on a journey about the AI. And we all speak about this cyberpunk future of the AI. And in the best case, AI should just take our jobs, right? In the worst case, we know what can happen. Yet, at the same time, somehow, my vacuum cleaner, my Roomba at home, cannot really get over the wires on the floor. So if we have AI invasion, make sure, just put enough wires in your apartment, they just cannot get over that. So keep that in mind. So where is the mismatch? How should it come from robot cannot climb over wires to robot taking our jobs? Well, it's really about the process. It takes a lot of time and a lot of effort to improve the AI in the way that it can climb over the wires and other terrible challenges on the way. So before AI can really replace human, there is a great deal of work to be done. First, there is a problem of skilled professional. Data scientists are one of the most rare and expensive professionals that are out there. And obviously, when we speak data science, we speak Python, so basically you. This is the first problem. Then there are data-related challenges, like a lack of available data. Companies having trouble to, even if they have the data, they have a trouble like prepare it, clean it, train a model, deploy it. They do not have the required environment, the required processes, and required strategies to do that. So maybe some of you heard about AutoML. Anyone did? AutoML is just a trendy word. It's automated ML, automated machine learning. It's supposed to do some work for these companies about the data cleaning and training and so on. So AutoML, it does indeed give big promises. And there are debates whether AutoML can replace, at least partially, some data scientists out there in these companies who are doing this job. Maybe AutoML can replace them, but not yet. So AutoML tools are alone is just a tool. It's not sufficient yet. They're crucial, but we still need to remember about the processes, about the methods, about the strategies. And AutoML is one of the tools that can make it faster to develop proper ML strategy in the company. Yet it cannot really replace the data scientists yet. So it doesn't work. Now, let's speak about, like, just to recap, because we all have different backgrounds in this room, what exactly I mean by AutoML and what exactly I mean by a lot of tasks that companies need to perform in order to like bring out their ML product out in the world. So this is a chart. I stole it. It's not mine. Yet still. It says that AutoML can basically cover only this top corner, which is build, train, and optimize, some feature engineering, some verification and assembling, yet it cannot, obviously it cannot do data acquisition, it cannot do data cleaning, it cannot do problem formulation, because only business can formulate a problem, and only a data scientist can understand the problem, formulate it, implement it. It cannot do the optimization of decisions. Again, it still needs human brains. It cannot do refinement, because again, we need a feedback from business. Why does this data looking not so good, not so clean, not so perfect? We need still constant feedback, constant refinements, constant optimizations to make the data ready for AutoML. And then finally, monitoring, of course, also still manual, and the deployment as well. And then the training itself, yes, it can be to some degree optimized with AutoML tools out there. So, as I say, at this point, this is just a buzzword to me. This is not sufficient yet. However, the tool I'm going to tell you today, it's not a magic bullet, it's approach. It's about integrating ML with apps and the change management. So assume now that we have our ML model built already, and we just need to deploy it. The classical deployment treats it as an application layer component as per this diagram. So you see that there is, I don't have a pointer. This is a traditional way like it works. We have the application, and the application is getting data from the model. Model is created, evaluated, trained, deployed, integrated, and of course it needs maintenance. Then the application is pushing the data to the database, always. Then between the database and the machine learning model, there is always some ETL, transformation jobs, pipelines, and there are BI tools down there in the right bottom corner when the business is actually looking at the data and evaluating the data. This is the way it currently works. It's basically a loop, a circle, going counterclockwise. That's how it works. And then integration with apps is also difficult because input is the data and we get the prediction as an output. Our business applications consume these predictions from ML tools via some APIs. And these APIs, as we know, are just APIs that have to be developed by developers and integrated. So it sounds straightforward for us. At the end, probably just an HTTP request with Python, but it's not as straightforward for non-so-technical people, data analysts even, and of course business people using standard BI tools like MicroStrategy, Power BI and so on, who just know SQL, maybe, and that's it. Training, again, like I already said that AutoML can partially cover this problem, yet still, like training, if we speak about the traditional training of machine learning model, only a developer can do it. That's exhausting. As we see above, data is the core of the AI process. And with existing ML tools, it's just complicated. So we have some questions, and we will try to find or propose a solution, which of course I know because I proposed this talk in the first place, but still. One solution that there would be is to prepare the model, and the second that I want to come up to is how to use that model. So it's actually a tool offering both. And probably we don't have enough time to discuss more on this, so I will just straight to the proposal. This proposal is how do we integrate ML models with apps? Why don't we embed it right into the database, right where our data sits? So we skip the part of ETL pipelines, we skip the part of data preparation, and we say we put ML capabilities right in place where the data resides, next to the data, in the database. This is how it would look like. So we have database, and we have just below the database some AI layer that is powering these extra features that database doesn't have, because database is just a storage. It doesn't have any sort of prediction mechanism whatsoever or AutoML capabilities. But we have a product called MindsDB that can enrich database capabilities, providing this. So before I go to MindsDB, a little recap, what do I have to do with it? So I don't work with them. I met them at PYDAY ODESA in 2019, and you need to understand, ODESA is not exactly the center of Ukraine. It was a one-day conference, that's why PYDAY, not PYDAYS, not PyCon, just one day. And yet, the guy flew from San Francisco to Kyiv, from Kiev to Odessa to present MindsDB. It was just like on the very, very basic stage on the prototype. This guy is up there doing this. He doesn't know yet that his company will become super successful there in San Francisco. At this point, George was just one of normal, busy guys, passionate with ideas like us here, and he presented on the stage in Odessa just like I'm presenting his tool right now, back then 4 years ago. And it worked. It worked, well, it's an untraditional company, I would say, because it's fully open source. We know that this concept exists, especially in the US. So they have, it's a normal company, it's now a big one, and they have funds and everything. Yet the majority, well, not majority, but a big amount of the features are still developed by a community, also from Europe, actually from all over the world. Because they need to integrate with a lot of tools. As I say, this is something that is enhancing the database. And there are how many databases out there? Postgres, MySQL, then there are non-relational, Mongo, I don't know, call it many. So it has to integrate with all of them. And the idea of George back then was that Jorge, he's actually Latin, Jorge, was to give a community the possibility to improve the products. And it worked. So now we need to go a bit in details. Later I still have time to show you a little demo how exactly it works. The core of MindsDB are AI tables. This is just a fancy name. Of course, they are not tables, but they act like tables. So the way it works is we have our client, end client application, I mean. We have MindsDB sitting in the middle, and we have the database. MindsDB is intercepting all the requests to the database. It reads in normal SQL. So you think you're speaking to database that you use like Postgres, yet you're speaking to MindsDB. MindsDB is checking what are you querying. If you are querying the actual database, it will just forward the request. If you are querying the data that is not in the database, but it can be predicted and there is a model, then it will query the model instead of the database. So actually when you're using it, you kind of don't even feel that it's in there. You think that the data is normal data, but it's not. It's a prediction. That's the magic of it. And they call it AI tables. Tables that don't exist, but they are based on the real tables with some prediction applied on them. Of course, to get these AI tables, you need to train it first. And they invented syntax that is also SQL-like, like you have create table, create database, and then you have create predictor. Using this data set, using that model, I will show you in a second. So they offer a normal SQL interface, but because it's a Python, of course, it's developed with Python, and they also have a Python developer kit. So you can also use it natively from Python if you want to avoid SQL for whatever reason. In my experience, developers would love to call it probably still with Python because, I don't know, elegant. You don't want to build another abstraction with SQL Alchemy whatsoever on the data that is not really existing, so the performance will be different. You cannot really treat AI tables the way you treat normal tables, so Python interface, perfect. But for the business, for people checking out this data in their fancy BI tools, drawing charts and so on, SQL interface is crucial. Like all the BI tools integrate with the SQL. That's why. So now let's go to the demo. Let's go to the demo. I hope my internet works today. There are many ways you can run MindsDB. One way is that you can use this easy web interface. It's just a demo data set that they have on their website. It takes like 1 minute to register and get there. Can you see? Yes, you can. Another way, you can run it in Docker locally, or the fancy way, you can deploy it on AWS or anything. So, and as I say, it's open source. So you just Docker pull the image, connect it to your database. It can also work locally. But I was lazy, so I didn't connect it. So I rely on the internet. Now, this is just a SQL shell. We will now create a sample database based on the data set in Postgres that already lives on the server. I'm copying and pasting here the syntax for it. This way we say to MindsDB that with this user, with this password, you connect to Postgres and you use that data over there to build your AI tables. Okay, query completed. Good. Now let's preview the data. Okay, here here we go. Not really well visible. Okay, so these are like rental prices. You see you have number of rooms, number of bathrooms, square feet because it's the US, location and so on. So this is a sample data set about the rental prices on the market. Good. We can also check the databases with normal syntax as we use in any database, more or less. Here we have this magic MindsDB, and we have example data that we just created. The other two you don't really need yet. Now let's create a model. About this syntax. So create model, as I say, it's SQL-like syntax. You give the model name here, and then with from, you are selecting the data that should be used when we are training this model. As easy as that. And here we need to specify the column that the system has to predict. Done. Let's look on the status. Status is generating here. We can always query the status with describe. On the bigger data sets, it will take longer. Here, it's a demo, again, provided by them, so obviously it's complete. So it's like generating, then it's training status, and then it's complete. So for us, it's all done now. We can also run show models, just to see models available there. There are some, because I was playing with it, predicting on the different columns. Okay, so now let's make predictions. This is how it works. We run, as I say, normal select. But here, instead of using from normal table, we specify the table, instead of the table, we specify AI table based on the model that we just created. So we say with number of bathroom 2 and this amount of square feet, tell us the price. Ooh, doesn't work. What's there? Syntax. Okay, we remove this. Yeah. I specified the argument that was not included in prediction. Again, I was playing with it, so in my notes it's like this. Yeah, so this is the prediction. Then we can also make batch predictions. Okay, these are batch predictions, there are many, and you see included here the second argument in my select statement, rental price explain. And it explains what exactly was applied. For instance, confidence is a very important factor here. So you probably want sometimes to filter that only show your predictions when you're confident about it. And it's not an anomaly and so on. So the explain column here, yeah, gives you basically all these details in JSON. And of course, you can fetch it with just normal Python query the same way. Okay, I think, yeah, that's probably it for the demo. Now I want to summarize. Let's summarize the benefits. So first, and main important, although it's my business, yet still we need no ETL pipelines between AutoML, if we're using it, and the databases. As I say, the data flows from database traditionally using some transformation pipelines to the ML model. And this is what I actually do at my daily job. I build ETL pipelines, like a lot of them. So yeah, kind of killing my own business, but yeah, this is just so much fancier and so much easier that I can share it with my friends. I will not share it with my clients. Then, there is no need for the API integration between AutoML and business application. By that, of course, I don't mean Python API, because this is nice, but the other APIs are ugly. So yeah, it's good if you can still query with normal SQL queries. Then, no need for the model deployment. Models are there just on the background, you don't see it. And yeah, I mean, this magic, it also feels to me a bit weird. Like, it's generating something, I don't know how, and it says it's confident about it. I'm not a developer of MindsDB, I'm a user, so I just used it in a couple of hobby projects, clicking around, that's it. I cannot really tell, like, this is the thing to use in production. Yet Jorge says that you can configure everything. You can even import the existing model. Like, if you train your model the proper way, you don't trust the magic of MindsDB, you can still just take that model out, put it in MindsDB, and just to get benefit of that SQL interface that it gives. So everything is configurable. Then, Of course, SQL queries. This is like a killer features for the BI tools. And the customizations, that if you really need it custom, you can still do that. That's it. I think we are perfectly on time, and I'm open for questions. As I say, I'm not a developer of it, so I cannot really give you any deep insights of how to do it, but as a user, ask anything. Thank you.
Great, thank you very much. There is only one question for now. Sounds quite useful, but also a bit risky. Isn't there a huge risk of feedback, models being trained on NI predicted data?
Well, there is always a risk when something happens behind the scenes, as I say, and you are not really controlling it. So if you're using this thing in production with Mongo, so apparently there are alternatives to SQL, but it will still provide your SQL. So Mongo can be behind the MindsDB, but you can still query MindsDB and therefore Mongo with SQL, again, because of the BI tools.
Great, thank you.
So the protocol between MindsDB and Mongo is apparently not SQL, but you will still speak SQL.
Great, thank you. And next question is, can we use different types of models, for example, classification, clustering, and show some examples?
Yes,
okay.
You can show different, you can use different types of models, that's for sure, and as I say, you can even use your own models. This is not a problem. I cannot really show you anything now because I'm using demo and it has just one. Yeah, go on mindsdb.com, you will see everything.
Great, thank you. Next question, which is actually like two questions combined. So first of those is, what processing power is needed?
Yes, and the results of predictions. Yes, both. I checked it. Processing power, I mean, I run it in my Docker, in my MacBook. I gave it like 1 GB RAM, so I do not think that it depends on the data sets, of course, behind it. So it can be 1 GB, it can be 1 TB. Like, depending on that, it's totally different requirements that we put also for MindsDB to fetch the data and train the data. So obviously it's not as much as requirements of MindsDB as the requirements of the training job that runs inside MindsDB. And they didn't invent it, so it's using traditional training algorithms out there, so I would say the same. But about the results, yes, I did verify the results and they are funny. As I say, you really need to put a bit of the effort to create high quality data. Like in this example that I was just showing you about the rental prices, it can predict price pretty well because it's a real data and they have a lot of data points. So it's this many square feet, this many square feet, this many square feet can be really easily mapped to the price that it will take. However, when I tried predicting based on amount of rooms and amount of bathrooms, it got funny. Like I said, predict me how many rooms will be in an apartment with 1 bathroom, for instance. Then it gets funny. So it got especially funny when I asked how many bathrooms will there be in an apartment of just 20 square feet. And it said 0. We see the traditional anomalies of machine learning there, so they of course still apply also in MindsDB. So to get the quality, you need to put extra effort, yes.
Thank you very much. Okay, and next question. Do you know how the models are trained? Is it neural networks or something else?
The default one, yes, it's neural networks, but you can specify how exactly you want to train. So you have a list of algorithms there that you can specify and use. I'm not sure it's all available in the sandbox, probably not, but if you run it locally, you can select.
Great, thank you. Next question, what's the quality of the model created? If I don't have an external model but a large database, will it generate a good quality model?
I would say if it's like really large database and it doesn't have this funny cases like amount of bathrooms that I say, that's always 1 or 2. It's rarely that you have 3 bathrooms or 0 of them. Yeah, so if you have more diverse data set, which as I said is, for instance, mapping square feet into the price, and there are a lot of data points, then it is of a high quality. However, it won't help you if you're querying on the data. There's a lot of data points, but it's not diverse enough. But this is again not something about MindsDB. It's something about general data science and machine learning. So all the rules that are applying in traditional machine learning and Python, the same rules apply for MindsDB, because behind the scenes it's just using traditional tools.
Great, thank you. Another question, can we customize our models or use a custom one? What about the hyper-tuning of the model?
Yes and yes. I didn't try hyper-tuning of the model, but you can customize it, yes.
Great, thank you. What type of models and algorithms MindsDB is using, like neural network, GPT or something?
I think it's not GPT. I cannot really answer this one. I don't know the name of it. It's just not GPT.
Yeah. Okay.
Yeah, the next one. Yes.
Does it train the model once, or is it a continuous process?
It is a continuous process, and this is important because I showed you at the beginning the loop of how it's done. Like, we have our model trained using the data from the database, using some ETL pipelines, and when ETL pipelines offloaded something in, I don't know, Parquet or whatever format we want to be using, and then based on that data we trained our model, then it's static. So for us to keep our traditional ML model up to date, we need to spin this loop always. With MindsDB, you can specify. You can either use like a trigger-based approach. When new data comes in the source table, it will regenerate the model. You can specify the rules. But yeah, the idea is to make it continuous.
Okay. Another question, can you give real-life like what a real-life application or platform is using MindsDB right now?
No. Let's Google. Let's Google, why not? I'm interested.
Maybe
myself.
somebody does it in production.
Maybe. MindsDB usage. Table, no. Tutorial. Examples? Probably not. Integration. It will probably it will take, I guess, longer. Then I think maybe they have some testimonials here. Yeah, AirTech is using. And Paystar. Yeah, it's US, so we don't know them, but somebody is using it. Next.
Yeah, next question, can you version models with MindsDB?
Oh, sure. And you can also do it with naive approach. At the end, you create a model just like you create a table. So you can script it. I mean, if you want, you can just have a name as a variable.
Yeah. Okay, so the last question for today, and I think you kind of answered it, but yeah, does it work out of the box? Is it cross-platform?
It is cross-platform because it runs in Docker. Yeah. And you can use it out of the box, but it will be a sandbox. So it's just for you. You have your projects, you have your data sets. Just out of fun, you can Docker pull, Docker run, map one port because it has a SQL interface as well as this UI, the same UI you get from the Docker. So you don't even need to have this getting started tutorial. You can click through the web interface to connect it to your database and see. Maybe it predicts you some fun stuff, and maybe you can offer extra features in your product. That's what I would say. Good approach.
Okay,
good.
Great. Thank you very much. This is it for the questions, and the next talk will take place in about 5 minutes, and it will be about polars versus pandas. What's the difference by Chuk Ting Ho.
Thank you.
Thank you very much.
Thank you very much.